All right, well, let's run through and do the practice test for this unit on integers. And so I'm going to write solutions at the top. Hopefully you're in the habit of putting first and last name on everything, date, period, all that. It's 3-hole punch, putting it in your binder and everything, so you can keep yourself good and organized and keep things nice that way. As we do these, I'm going to focus in on each problem almost one at a time and think through it, kind of like we'd focus on something on a test. So I'm going to zoom this in quite a ways and then just kind of slide things around as we get to them. So we'll notice on this problem that we've got two integers that we're going to combine. There's no division symbol there, there's no implied multiplication, so we're definitely going to combine these. This is understood to be positive. So what we've got here is we've got different signs. If we've got different signs, we're going to find the difference. If you need to do a little subtraction problem off to the side and figure out that the difference is 6, that would be fine. But remember, the answer is not plain old 6. We've got to figure out whether it's positive or negative. So we look at the two numbers, and again, if you need to, I recommend kind of covering up the signs. The 15 is definitely bigger, and it's negative, so the answer on this one is going to be negative 6. Slide over and take a look at the next one. We see a problem with this one is we've got some implied multiplication here, and we've got two symbols in front of that 5. So we're going to rewrite this. We're going to rewrite this as negative 6, and then a positive times a negative is a negative, so this is going to be negative 6 minus 5. Same sign, we're going to find the sum. The sum is 11, and we keep the same sign all the way through, so that's going to be negative 11. Again, once you rewrite it and you think of a money analogy here, you owe $6 to one person, owe $5 to another person. That means you're going to owe $11 altogether. We've got some rewriting that needs to be done on this one as well. So this is going to be negative 4. Negative times a negative is a positive, so that's a positive 4. They've got different signs, so we're going to find the difference. The difference between 4 and 4 is 0. And this is kind of unique when this happens. Sometimes people freak out when there's a 0, but it's just as good as any other number. The other thing is we don't have to figure out the sign because 0 is neutral. It's right in the middle. And if we were to say, well, they're different signs, find the difference and then find the sign of the larger one, they're both the same signs, or same size. So the answer to that is just plain old 0. Rewriting to do on this one, 9 and then minus 3. That's technically positive. We could just go through and do this problem and write down that the answer is 6. We know that from elementary school. But again, if we applied the rules, different signs find the difference. The difference is 6. The bigger one's 9 and it's positive, so the answer is positive 6. So we'll keep going here. I'm going to go in numerical order here, just like we would on a test most likely. So this is negative 4 minus a negative 11. So negative times negative is positive. Different signs, so we're going to find the difference. The difference is 7. The bigger one is 11 and it's positive, so the answer is positive 7. And again, at any time you can go back and review this video. You can pause it, think your way through it. You can go back and look at each one of the sections and watch how to do these again, get some more explanation. 13, negative times negative is positive. Same sign, find the sums. So we're going to have 18. They're both positive, so the answer is positive 18. No rewriting necessary on this one. They're both negative, so let's see. Same sign, we're going to find the sum. The sum is 16, and they're both negative, so the answer is negative. Again, if you wanted to run through a money example on that one, that would be great. No rewriting on this one either. Different signs, find the difference. The difference is 6. The bigger one's 14, and it's negative, so the answer is negative 6 on that one. Let's take a look at these other problems here. We've probably got some multiplication and division coming up here. Implied multiplication here, fairly big numbers. Let's compartmentalize and let's figure out the sign first. This is a positive times a negative, so the answer is going to be negative. If you need to do this off to the side to figure out what the answer is, that's totally okay. You're welcome to do this. This ends up being 45 here and 90 here, so you end up with 135. Okay, so there's the answer on that one. Let's take a look at number 10. We've got a negative divided. This is a division problem, and again, if you're more comfortable with this, I certainly am. I like writing them like that with that horizontal division bar, nice flat division bar, fraction bar. Negative divided by a negative is a positive, so the answer is positive, and 30 divided by 6 is 5, so there we go there. Negative times a negative is a positive, and 4 times 4 is 16. Really not much work to show on that one. Let me slide this up. Okay, here's our horizontal fraction bar. We've got a positive divided by a negative, so the answer is going to be negative. And 27 divided by 3. 27 divided by 3, hopefully you got those times tables memorized so you can do that really quickly. So negative 9. Come back over here and do these next couple. I'm hoping this test goes pretty quickly, but I'm also hoping everybody gets 100%. There's a negative divided by a negative. We've got a positive. 44 divided by 11 is 4, so positive 4 is the answer there. Whoops. Let's see, on number 14, negative times a positive, answer is going to be negative, and 13 times 5, if you multiply those two together, you get 65. And again, if you need to do some stacking or something like that, do 13 times 5. You're welcome to do that if that helps. Let's see, negative times negative is a positive, 4 times 12, hopefully have that from our times table, so it's going to be positive 48. And then again, another division problem right here. A little bit bigger numbers, but I think we can deal with this. Let's see, a negative divided by a positive is going to be negative. And then if I did 8 into 112, let's see, it goes in there once. That would be 8, that would be 3, 32. Okay, so we've got a 4 there, that would be 32, and then it would go in evenly. So the answer on this one's negative 14. And if you need to show some work like that, there's no problem with that whatsoever. Now let's take a look at this one right here. It says define and give an example of each of the following. So we've got additive inverse, additive identity, and then we've got something here. I got a star by this one. This says multiplicative identity. Let's come back to that one at the end here. But let's see what we've got. Define and give an example. So let's see, additive inverse. We're going to add and do the inverse. So this is add and undo. So maybe an example would help. What if we did something like this? 4 minus 4. This is a positive 4. There's the additive inverse. That makes a 0. Okay, so the definition of this is they add to make, make 0. Okay, they are opposites of each other. Okay, and we could give another example. Let's say we started off with a negative 7. The inverse of that, or additive inverse of that, would be positive 7, because if we added 7 to that, that would make a 0. Okay, so we've got a couple examples, and we've kind of got our definition here. That means they add to make 0. Additive, so we're going to add an identity. Remember when we talked about this? This means the identity, the number gets to stay the number that it is. It maintains its identity, just like you have an identity. So we're going to say stays the same. So it is, let's see if we can come up with an example. Additive identity. What number would we add so that it stays the same? Let's do that 4 again, and let's add, well, we want the answer to be 4. What would we add to make sure the answer stays 4? It would be 0. And let's say we had like a negative 15. If you added 0 to that, it would maintain its identity. It would stay negative 15. So 0 is the additive identity. It's the number we add so that the number stays the same. Okay, and in parentheses, number we add so it stays the same. Hopefully that makes sense. So let's think about this one right here, the multiplicative identity. Well, this would be obviously multiplying. Okay, multiply an identity, it's got to stay the same. So let's think about this. What number would you multiply to make a number stay the same? So let's start with that 4, and let's multiply by something, and let's keep it, keep it a 4. Well, what number would you multiply so a number doesn't change? Well, you'd multiply by 1. And it works the same with numbers like this, like negative 10 times 1 would be negative 10. Negative times a positive is still a negative, so that maintains its identity. Okay, so we're going to say 1 is the multiplicative, big word there, multiplicative identity. Okay, And we'll say number we multiply by to stay the same. That's probably a better way to say that. Number we add to stay the same. Okay. So 0, and I'll write a number for that. 0 is the additive identity and 1 is the multiplicative identity. All right, now a couple easier problems here. We haven't done these in a while, haven't done a whole bunch of these, but this is just absolute value. And the question here is, how far are each one of these numbers from 0? Because remember, that's what absolute value is. It represents the distance from 0. So this is literally asking, how far is 0 from 0? 0. How far is negative 9 from 0? 9. How far is negative 200 from 0? 200. And how far is 20 from 0? 20. So the absolute value doesn't care which direction we go, whether we go to the left and have a negative number or go to the right and have a positive number. It just cares how far. Okay? All right, so last couple problems. Write an integer expression to model the following problems, then write the answer. So the temperature at 5 p.m. is 18 degrees. By 7 a.m. the next morning, the temperature has dropped 20 degrees. And then at 9 a.m., the temperature has risen another 13 degrees. What is the new temperature at 9 a.m.? All right, so we got a bunch of numbers and times floating around here. Let's kind of dissect this. Okay, we start out at 5 p.m. and it's 18 degrees. Now it says 18 degrees, so we'll assume that that's above 0. So 18 degrees above 0 would be positive. The temperature dropped 20 degrees. So if it dropped 20 degrees, now it doesn't say it dropped to 20 degrees, it just says it dropped 20 degrees. So that's going to be a minus 20. And then it went up another 13. So it's going to be up 13. So this is 5 o'clock the previous day, then by 7 in the morning, and then by 9 in the morning. So let's see what happens here. If we put these together, we get negative 2, and then we're going to add 13. Different signs, find the difference. So we end up with, this is going to be 11 degrees. There's our answer. So again, here's kind of the thinking and the thought process and the integers that go into the problem, and then there's the number answer right there. Scuba diver dove down 48 feet to look at a sunken ship. She then rose 21 feet to look at a fish and dove 14 feet to get away from an octopus. Okay, so she dove down, so we'll represent that as a negative 48. Rose up, went the other direction, so we're going to represent that as a positive 21. And then dove down again, so this is going to be a minus 14. So let's see, different signs, find the difference. The difference between the two of those is 27 and the bigger one is negative, so she's still 27 feet below the surface. And then this would be minus 14, same sign, so we're going to find the sum. So that is going to be 41. 41, yep, 41, and that would be negative. We keep the same sign. Negative 41 feet. Okay, so I'm going to circle that. There's kind of our work. If we wanted to explain this, we could say 41 feet below the surface. That might be nice to do. Okay, last one. Costs $56 to rent a rowboat. You and 6 friends decide to split the cost. How much do the 7 of you, remember it's you and 6 friends, so there's actually 7 of you all together. How much does it cost to rent the rowboat? How much do each of you owe for the rowboat? So we're going to represent the owing $56 with a negative, and we're going to divide that by 7 friends. So that means negative 8, and I'm going to put a dollar sign on there. We could circle that. So again, here's kind of the work. There's the answer, and we could say each owes $8. Okay, so there's kind of an explanation of what that negative means. It means they each owe. All right, that's it. If you need to do this several times, watch this video a couple times. Go back and watch the other videos from the section and from the unit. That would be okay, but make sure you're ready for the test and then kind of score yourself on that I can checklist that we've got available. So thank you very much.